Hi, today I'm going to try using really cheap power modules sold on Amazon. They're in this package. 12.90 yen per 10 modules. They're sold for 129 yen per module. Unbelievable. This is the power module. It's a DC-DC step-down converter. The input voltage is 3.2 volt to 42 volt. Since it's a step-down converter, the output can be set from 1.25 volt up to 35 volt. When you use a step-down converter, the input voltage must be higher than the output voltage. In other words, the output voltage will be lower than the input voltage. The attached IC is LM2596 made by National Semiconductor, currently owned by Texas Instruments. It's an IC for DC-DC step-down converter. On the back side, there's the IC's part number. It says DC-DC and an arrow. The arrow shows the direction of the current. This IC usually costs 200 to 300 yen each. However, this module costs only 129 yen, including the circuit. I don't understand why this is so cheap. Well, I guess there are some reasons. Using this module is easy. Connect the power to the part where it says in. Once again, I connected the DC-DC converter module to the power supply. The top meter shows the input voltage. It's 28 volt now. The bottom meter shows the output voltage of the DC-DC converter, which is set to 5 volt. If I change the input voltage like this, the output voltage keeps 5 volt. Performing well, you can change the output voltage by turning the variable resistor. The datasheet of this module says the lowest output voltage is 1.25 volt. My meter says about 1.25 volt too, about the same as what the spec says. Let's raise the input voltage. The spec says the input voltage can be up to 40 volt, so I'll set to 40 volts. Now let's raise the output voltage. How high will the output voltage go up? Almost the same voltage as the input. You should note that the withstand voltage of the capacitor at the output is 35 volt. So I think it's better not to apply voltage above 35 volt. I guess it's fine to exceed by 10% or so, but I can't say for sure. I can't be sure about the maximum output voltage without the spec information of the DC-DC converter IC. Let's check the datasheet later. This module is a step-down power module, so the output voltage is always lower than the input. It comes in handy when you want to produce a voltage that's lower than the source voltage. It's only 129 yen each. I think it'll be very useful for when you do electronic work at home. This one is a step-down converter, but there are boost converters as well on Amazon. I'll show you those another time. Next, let's look at the datasheet of the IC used in this power module. This is the datasheet of the DC-DC converter IC. Product number is LM2596, currently sold by Texas Instruments. Apparently there are two types, fixed and adjustable output voltage. The one I'm using today is an adjustable type. The input voltage is up to 40 volt. The output voltage range is from 1.2 volt to 37 volt. As in the experiment earlier, it seems the actual maximum output voltage is a bit higher, but on the datasheet, the maximum is 37 volt. The output load current is 3 ampere at most. The module's circuit structure is the same as the typical application circuit diagram on the datasheet. LM2596 consists of a bipolar transistor and a feedback circuit. The feedback circuit keeps the output voltage constant. So the circuit structure is simple. Then there's an external diode, it's a Schottky barrier diode, and there are an inductor, an output capacitor, and resistors for feedback. One of the resistors is a variable resistor. The two resistors create divided feedback. According to the datasheet, you could connect a capacitor for phase compensation, but it's not connected to this module. I removed the parts from the module to see the circuit board. It seems you can use the same circuit for both the fixed voltage converter and the adjustable converter. A variable resistor was soldered here. If you have a close look, you can see that you can solder a fixed resistor there. I can't find a place to solder a phase compensation capacitor. So if you need phase compensation, you need to solder the capacitor on the backside. To check the performance of this module, I connected it to an oscilloscope. I'll look at the ripple voltage, which shows how much the voltage varies. The input voltage is 12 volt. The output voltage is 5 volt. The output current is 1.5 ampere. The voltage ripple is huge. The scale is 0.1 volt per division. It means there is a ripple voltage of approximately 0.4 volt peak to peak. The voltage varies by 10%. 10% of voltage variation is really huge. This module is no good. There might be something wrong with it. I found out a shocking fact just now. When you use a step-down converter, the distance between the two troughs or two crests of the output voltage is the wavelength. I found out that the switching frequency is only 18 kHz. This IC used for this module is Texas Instruments LM2596. Its datasheet says the switching frequency is 150 kHz, but this module switches at 18 kHz for some reason. This particular module might be just malfunctioning. There are still many other modules, so I will try those as well. I'm using another module, but the switching frequency is about 50 kHz. It's also less than 150 kHz, which is written on the datasheet. I'll try other modules too. I'm using another module. This one's switching frequency is also 53 kHz. I checked all of the remaining modules. All of them had a switching frequency of 53 kHz. It's very likely that the one with 18 kHz frequency is broken. The datasheet I downloaded from the Texas Instruments website says the switching frequency is fixed at 150 kHz. However, this module only has 53 kHz. I think the IC used for this module is probably a fake. It's very possible that the IC is not genuine. In the first place, the pricing was strange. If you buy 1,000 genuine ones, the price will be approximately 300 yen each. However, if you buy this module, you can get it for 129 yen each. For some reason, it's cheaper to buy a module than to buy an IC. Also, the font of the logo printed on the IC is not consistent. The package I bought included 10 modules. For some reason, 2 types of fonts were used on them. Even if they were manufactured in different factories or in different lots, the corporate logo and characters wouldn't be printed in different fonts if they were manufactured by the same manufacturer. Also, the design of the ICs is a bit different. This one has short legs for soldering, but the other one's got longer legs. And on the back side, there's a part where the metal is exposed. The shape of the metal part is also different. I'm pretty sure the IC used for this DC-DC converter is a fake. However, this module works normally. It's not good that they use fake ICs, but the modules work properly. The switching frequency is 50 kHz, which is 1/3 of the genuine products. So the output ripple voltage is pretty high. If you want the ripple to be as low as the genuine products and still want to use this DC-DC converter, you need to connect a big capacitor to the output. Also, because the switching frequency is low, when the load changes abruptly, the response to the change tends to be slow. When you use this module, keep those things in mind. High ripple voltage and a little bit slow response to changes of the load. Also, I measured the efficiency. The input voltage is 12 volt and the output voltage is 5 volt. The maximum efficiency is about 81.5%. Well, I think it's good enough for this amount of wattage. The efficiency is the lowest when 3 ampere is applied to the load, which is 71.2%. This means approximately 6 watt of heat is generated on the circuit board. I would also like to measure the efficiency when the output voltage is changed. Currently the output is 5 volt, 3 ampere. The maximum temperature is 113 degrees Celsius. The module is overheating. Now it's 115 degrees Celsius. It's obviously impossible to use this module at the rated current of 3 ampere. Now I'm applying current of 1.5 ampere, half of the rated current. The temperature is 65 degrees Celsius. It's still quite high. You can apply at most 1.5 ampere, and in that case you need heat dissipation measures. You need to cool it down with air. If you don't have heat dissipation measures, then you can apply at most 1 ampere, I think. Now, let's summarize today's video. Well, the IC is a fake indeed. However, even with a fake IC, the module works properly. When the input voltage changes, the output voltage stays the same. You can change the output voltage as well. I don't want to say this, but for a module that costs only 129 yen, it's not bad actually. But it uses a fake IC. I have mixed feelings about this module. There was no need to use fake ICs. If they use fake ICs, at least I want the corporate logo to be removed. This power module we use today has low switching frequency. Because of that, the output ripple voltage is a bit high, and there's some delay when it responds to abrupt changes of the load and input voltage. If you are careful about those, the module works without problems. Well, that's about it. Thanks for watching